Alright, so we're going to continue looking at unit circle trig. Okay. Yesterday, we started looking at a little bit of unit circle trig. And what we did is we examined these four angles. What, not the coordinate, but what is the measure of each of those angles? We'll start with the one on the right.
90?
That's the one at the top.
What? Oh.
So 90's at the top.
0, 180, and 270.
Okay, 180, 270. And now, what was the coordinate for 0? 1, 0. How about the coordinate for 90?
0, 1.
0, 1. Okay, and 180?
0, 1.
We already used 1, 0 over here.
Negative 1, 0.
Negative 1, 0. And 270.
Negative 1, 0.
0, negative 1.
0, negative 1. Now, using those x and y values, you can find the sine, cosine, the tangent, the cosecant, secant, and cotangent for any of those angles. But the important thing is you know the coordinate. Today, we're going to look at these three. 45, 30, and 60. Okay. First thing to notice is how they are spaced. They are not equally spaced between 0 and 90. It's like you kind of have a gap here. You're missing that one, and you're missing that one to make them all equally spaced. The blue ones are not ones we look at. Okay, we just look at the three red ones. So that's your 45, 30, 60. Okay. So those are the three angles we're going to look at today. So in order to do the unit circle trig with those three angles, what is it that we have to know about each one of them?
Coordinate.
Yeah, we got to figure out the coordinate. The 30 and the 60 are connected, and then the 45 is separate. Okay, so we're going to start by looking at the 45. And once you know how to find the 6 trig functions of the 30, the 45, and the 60, finding them in any quadrant, 2, 3, or 4, is very similar to doing them in quadrant 1. Okay. But today we're mainly going to focus on quadrant 1. All right, so first I'm going to draw my unit circle diagram, and I'm going to put the 45-degree angle on it. Remember, 45 is exactly halfway between 0 and 90. Okay, so here's 0, here's 90. And with unit circle trig, what you're basically looking at is an angle, like that. And you're looking for where the terminal side of the angle hits the edge of the circle. That's the coordinate we want to figure out. To figure out that coordinate, what shape did we draw inside the circle?
Triangle.
Yep. So we're going to make a triangle by drawing a line straight down, just like that. So here's my 90. And the hypotenuse, we know how long that is, because that's a unit circle.
1.
Yeah, this is 1. Because the hypotenuse of that triangle is also the what of the circle?
Radius.
Yeah, the hypotenuse and the radius are the same thing. Yep. Okay, so I've drawn that same triangle over here, just a little bit bigger. Okay, I've also labeled each angle. This one at the bottom is a 45, because that's how much we've tilted the hypotenuse to point at the 45. Now, because I know this is a 45, how do I know the one at the top is a 45 as well?
Minus 180.
Yeah, these all have to add up to 180. So if you know that's a 45 in the lower left, because that's the angle of the hypotenuse, then you can add it up and subtract from 180 and get the one at the top. Okay, so now to figure out the coordinate, we basically have to find the length of 2 of the sides of the triangle. You have to figure out how long the bottom side is. And that is your x. It's how far you go from the origin to the right. Okay, so we're going to figure that out. Then we have to figure out the y. The y is how far up you go from this point to get to there. So the two values we need to find are the two lengths of the sides of the triangle. How long is the bottom, and then how tall is it? Now we don't know either one. Okay, all we know is the hypotenuse. But what kind of triangle is that?
A squared.
It's a right triangle. What other kind of triangle?
It's a special.
It's isosceles. Yeah, it's a special right triangle. Specifically, though, it's isosceles, which means what?
You can use Pythagorean theorem on it.
We can use Pythagorean theorem, not because it's isosceles, though. We know the legs are the same. Yeah, very good. These two legs have to be the same because we have two angles that are the same. That's what makes it isosceles. We don't know either one of those legs. Okay. When we don't know something, like a number in math, how do we represent it?
An X.
Yeah, we use some kind of letter.
Or a Y.
Or a Y, yep.
Or a
You could use A and B in
Or
a
an
triangle. Yeah, we don't want to use I because that's imaginary.
Or-
We'll stay away from that.
Okay.
But let's use X.
Okay.
So if we call the bottom side X, what letter would I use for the height?
X.
We have to use X because they are the same. If you pick a different letter for each side, then you're saying it's not isosceles. You're saying they're different. Okay? Any question why we labeled each side X? It really doesn't matter what letter you use. All right, so now we want to solve for X. And once we know X, that's the blue side and the green side in the triangle, or the first part and the second part of the quadrant. What theorem can we use with this,
Pythagorean theorem.
that, and that?
3, 4, 5.
No,
No.
not a 3, 4, 5 right triangle.
Pythagorean theorem.
Yeah, let's set up the Pythagorean theorem and then solve it for X, and we'll have our answer. How would I set up Pythagorean theorem with those three things?
1 squared equals x plus x.
1 squared equals,
X squared plus x squared.
yep. Okay, we can do out 1 squared. 1 times 1 gives us 1.
Can you combine them because they're like terms?
Yep. So we have a 1x squared and a 1x squared. So when we combine them, how many x squareds do you have?
2x squared.
Yep.
Yeah.
Okay, so we have 2x squared. What would be my next step to start getting the x by itself?
Square root.
We are going to square root, but we're going to hold off on that till the next step. One thing we have to do first. So we're getting x by itself. I think you guys had just started to say it. What was the next step?
Square root.
Pythagorean theorem.
No, we already did the Pythagorean theorem. Now we're solving. Yep. So we divide everything by 2. So the 2's here cancel. And we almost have x by itself, but there's one more
Square
thing.
root.
Take the square root. When you square root a fraction, the way you do it is you do the top and you do the bottom separate. Take the square root of each part of the fraction. Squaring and square rooting, what happens there?
Cancel.
Cancel.
So the only thing left on the right side
Is X.
is the x. Now let's take the square root here. What's the square root of 1?
Square root of 1. Like it would just be 1.
1. And now does the square root of 2 come out nice?
No.
No. Just
No, unfortunately it doesn't, which means it's in the bottom, but we can't leave it there. How do we fix the square root in the
Multiply by
bottom?
square root of 2 on the top and the bottom.
Yep, so multiply top and bottom by square root of 2. And what do you get in the top?
1 square root of 2.
1 square root of 2, or just square root of 2. And the square root of 2 times the square root of 2 is the square root of 4,
4, which is 2.
which is 2. So that is what x equals, the square root of 2 over 2. So now we know how long the bottom side is, and we know how tall the triangle is. How long is the bottom side?
2. Square root of 2 over 2.
Square root of 2 over 2. And how tall is the triangle?
Square
Square
root
root
of
of 2
2
over
over
2.
2.
Square root of 2 over 2. So when I write the coordinate for 45 degrees, what's my x value?
Square root of 2 over 2.
It's square root of 2 over 2. That's how far over I have to go to the right. And then how far up?
Square root of 2 over 2.
Square root of 2 over 2. And that is a coordinate we saw yesterday. We didn't know how it came up. I just gave it to you, but now you know where it comes from. It comes from the Pythagorean theorem. Okay? So that is always the coordinate for 45 degrees, and we don't want to have to go through and figure it out again. So we want to remember now, anytime you have a 45-degree angle, the coordinate is root 2 over 2, root 2 over 2. That's the coordinate. Never changes. Okay. Any question on how we got that coordinate? Now, once you have the coordinate, you know the x value, you know the y value, you can fill them into the formulas we learned yesterday. All right. So let's try finding the 6 trig functions of 45 degrees. Okay. When they ask you to find the trig functions and you're using the unit circle, what's the most important thing that you need to know?
The coordinate.
You need the coordinate. What did they give me in the problem right here?
The degree.
They gave me the degrees, right? They gave me the angle. The angle is not what's important. You have to use that to get the coordinate. So now we either go through and we have to figure it all out from scratch again, or we just remember what is the coordinate for 45 degrees.
Square root of 2 over 2, comma, square root of 2 over 2.
Yep, perfect. And this, I think, was example 2 yesterday. We've already actually done that exact problem. The difference yesterday is I gave you the square root of 2 over 2. Today, you had to know that it's the coordinate for 45 degrees. Okay, but we've done this exact problem. We can go through it again. Let's do the sine. What's the definition of sine? It's the
Y.
y value. What's the y value in this case?
Square root 2 over 2.
Yep. If you mix the x and the y up, you'd be okay in this one because they're the same. But in general, you can't mix them up because a lot of times they're not the same. So root 2 over 2. How about the cosine of 45 degrees? What's the formula for cosine?
Square root of 2 over 2.
Because the formula is
X.
x. Yep. So x is square root 2 over 2. How about my tangent? That's
It's y over x.
It's y over x. So what I do kind of visually is just imagine putting a division line right there, and you're dividing this one by this one. What's y divided by x?
And flip.
You can do it all out, but look at y and x.
Or would it be 0? Or 1?
How do y and x relate to each
Cancel
other?
out. Like they're the same.
Square root of 2.
They're the what?
They're the same.
They're the same. So what do you get when you divide two numbers that are the same?
Oh, the same
One.
number.
1. No, you get 1.
Oh.
Like
Yeah,
4 divided by 4 is 1.
45.
Okay.
Same thing with the
Now, once we get the 3 on the left, what do we do with each one of them to get the 3 on the right?
You flip them.
Flip them. Yep.
Yeah.
Does anyone remember from yesterday what you get when you flip root 2 over 2?
That's the square root.
It's just the square root of 2. Okay,
Yeah.
we went through that one yesterday. Anyone want me to go through it one more time, how you get it? So when you flip it, you get this. And then when you multiply top and bottom by root 2, you get 2 root 2 over 2.
So, cosecant is just the sign flipped.
The cosecant is the sine flipped. Yep.
But if the sign was like 2,
Well, the sign would never be a number bigger than 1. We haven't talked about that, but it would always be a number less than 1.
okay.
It wouldn't be 2.
So like 1 over 8, the cosecant is going to be 8 over 1.
Yeah. Yep. And now for secant, what are we going to get for that?
Square root of 2.
Yeah, because the sine and the cosine are the same. So the cosecant and the secant are the same. And how about the cotangent?
1.
1. Because you're going to take the tangent and flip it, but there's two numbers you can flip and they don't change. That's one of them. What's the other number you could flip and it stays the same?
0.
No, if you flip 0, what do you get?
Undefined.
Undefined, so that's different. But there's another number you can flip and it doesn't change it, besides 1.
Infinity.
No, infinity's not a number.
That's true.
What is it? Well, 1 is one of the numbers. There's another one. Yep.
Negative 1.
Negative 1. If you flip negative 1, you still get negative 1. Okay, so that's the 6 trig functions of 45 degrees. On a, yeah.
Secant is, what, sorry, I forgot what we did in secant.
Secant is when you take the cosine and you flip it.
Okay.
Yeah.
And then tangent is,
Tangent, cotangent is when you take the tangent and flip it.
oh,
Yep.
there.
That's why I put them in the same row, so you remember, once you get the 3 on the left, you flip each one of them to get the 3 on the right. Yep. All right, so now I just want to kind of take a look at something. Let's say we had, again, this, I just want you to watch this, just watch what I'm drawing. Let's say I had this angle over here, exactly halfway between 90 and 180. What number is halfway between those two?
135.
135. Okay. Now, think about the triangle we had before. This is the 45. Right? And
Would
it
it be the same as negative?
would look like that. Here's the 135. How do those two triangles connect to
The
each other?
opposite.
They're reflected.
Yeah, they're reflections. So both sides were root 2 over 2, root 2 over 2. Same thing here. Root 2 over 2, root 2 over 2. The only difference with 135 is you went left, which means it's what kind of number?
It would be a
Right,
negative.
it's a negative. So once we know how to do the 45-degree angle in quadrant 1, doing it in quadrants 2, 3, or 4, all comes out the same. They all are the root 2 over 2. The only difference is sometimes one of the numbers or both of them are negative, but it's the same steps. Okay, we're going to look at those quadrants more tomorrow. But if you understand quadrant 1 today, it's very easy to do tomorrow. All right, so that's the 45. Now we're going to look at the 30. Okay. Well, when you're looking at the 30, you're actually looking at the 60 at the same time. Okay, they're the same. It's kind of the same thing. So let's look at the 30. So here's 0. There's 90. And we're going to draw roughly where 30 degrees would be. Well, the whole quadrant is 90. 30 is how much of 90?
Third.
A third of it. So try to draw the angle, or try to put the dot like a third of the way through the quadrant. Maybe something like that. All right. So the hypotenuse, that doesn't directly help us, but it will a little bit. What do we know the hypotenuse is?
It's the, across from the, or, I don't know how, something.
Thinking about how long it is.
1.
1. We know the hypotenuse is 1 because it's the radius of the circle. It's the same hypotenuse as the 45. Now let's label our angles. This is the 30. The reason it's the 30 is because that's the angle the hypotenuse is at to point at the 30-degree mark on the perimeter. What would this angle at the top be?
60.
That's my 60. Okay. So I've drawn the same triangle, just a little bigger off to the side. All right, now the first thing I asked last time was what kind of triangle is this? Same question this time. What kind of triangle is that? It's a right triangle, but I'm thinking of something else.
Acute.
No, right, if it's right, it can't be acute.
Yeah.
Yeah, so it's right.
Oh, 30, 60, 90. That's a thing.
Okay, so it is a special right
Like, none of
triangle.
the angles are the same?
Yeah, none of the angles are the same, which makes it what? Isosceles is when two are the same.
Equilateral isosceles is freaking scalene.
Scalene, yeah. This is a scalene triangle. Okay. The problem with a scalene triangle is all the sides are different. So if you wanted to use Pythagorean theorem, you would need a different letter here and a different letter here. We can't do that.
Wait, why not?
Because if we set that up, how many variables are going to be in? Yeah. You can't use Pythagorean theorem if there's two letters for sides. Okay? Can only do it with one. So what that means is we've got to figure out one of these other letters a different way first. Then we can use Pythagorean theorem. Okay? So let's kind of give you a hint. It's not, you just have to be a little clever with how you do it. It's nothing that complicated, but if you don't think this way, it might be hard to figure out the step you need to take. So let me give you a hint. Okay. That's my hint. So I'm trying to figure out the length of one of these other sides first, without Pythagorean theorem. Any suggestions based on what I just did there? Yeah.
So if you flip one of them, like if you, like, I don't know.
Make it a rectangle.
If you like reflect it, I guess,
Mm-hmm.
so that both of the 60 degrees are on the top, but the 30 degrees on the other side. I don't know how to like say that.
Okay, what are you trying to make here?
An isosceles triangle.
Trying to make, okay, so I think you're trying to do something like this.
Yeah.
Okay, so I like the idea of making a triangle, definitely. I know I heard rectangle too, you could do that. But I like the idea of making a triangle. But I'd like to make a different triangle. That is definitely isosceles, but I'm not sure what we would do with that.
You could do it the other way, so that the long sides match up.
We could do it so the long sides match up. Yeah, let's flip it that way instead. I think I still need to keep it flipped that way.
Wouldn't that just make a rectangle?
No, I need to flip it back the way I had it. There we go. So now the long sides match up. Okay, and look at what we just made.
Oh, that's an equilateral.
Right, we just made an equilateral triangle.
So
That's 60, that's 60,
That's 60.
that's 60. We know this side is 1, this side is 1,
Which means the bottom is 2.
1.
which means this side is how much?
1.
This side is 1. That's what I really care about.
And half of one.
It's 1/2.
Yeah. And we know that this piece in blue and this piece in green are copies of each other. They're exactly the same thing. They're mirror images. If they're the same length and they have to add up to 1, that means each one of them has to be how much? Each one of them has to be a half. So now, just by doing that clever little trick, we've figured out one of the other sides. Now we can use Pythagorean theorem. We don't need the bottom triangle anymore. So any question how we figured out this side right here is a half? It's probably the easiest way to figure it out without really doing a ton of math. Just making a copy of it and looking at what you created. All right, now let's move this out of the way.
Is there a rule for that?
No, just just being
Just for this problem that way?
yeah, just being clever with making a copy of it and looking at the fact you ended up with an equilateral triangle. Yeah, just a special trick. Okay, so now we know that side's a half. We still don't know the bottom side, but what could I call it temporarily?
X.
Yeah, we'll just call it x. And now you know 2 out of 3 sides, so let's use Pythagorean theorem. How would the Pythagorean theorem look setting it up with those 3 things?
So that's x squared plus half squared equals 1 squared.
X squared plus a half squared equals 1 squared. Okay, what's a half times a half? That's a half squared.
Quarter.
That's a quarter. And 1 squared is 1. What's the next thing I would do with the quarter?
Subtract it.
Good. We'll subtract it to the other side. If I take 1 and subtract a quarter, how much am I left with? 3 quarters. Perfect. And now that's x squared, but I want x. So what's the last step to get rid of that exponent of 2?
Root 1. Square root of
Yep, we're going to take the square root.
Okay, I decided that x was 1.
What's that?
I thought x was 1. Because
No, the hypotenuse is 1,
Oh, yeah. Okay, never mind.
because that's this side.
Yeah.
But we don't know this side,
Yeah.
right there.
I get it.
It's close to 1. If it went all the way, it would be 1. But
Yeah.
it's a little bit shorter than 1. It's about 0.8 something. We're going to figure out what it is. So we take the square root on the left, and those cancel. How do I take the square root of 3/4?
square root of the top and the bottom.
Yep. Square root at the top, square root at the bottom. Does the square root of 3 come out nice? No. Does the square root of 4 come out nice? What is that? 2. There you go. That's the length of the bottom side of that triangle. Square root 3 over 2. Okay, so now we know how long that side is. Looking at our diagram, square root 3 over 2. And we know how tall this side is. How tall is that green side?
1/2.
1/2. So now let's write the coordinate for 30 degrees. What's the x value going to be in the coordinate for 30 degrees?
Square root of 3 over 2.
Yep, so it's how far over you have to go. Square root 3 over 2. And then how far
1/2.
up? 1/2. And that is always the coordinate for 30 degrees. Root 3 over 2, comma 1/2. All right, now let's look at the 60. So the 60 is up here. If you make your triangle, you have something like that. How does the triangle, let me just make them different colors. How does the triangle that I just drew in blue compare to the triangle in green?
It's like the same, but up.
Yeah. They're exactly the same triangle, except the blue one is standing up, and the green one is kind of on, it's on the long
Would
side.
you just flip them?
Yeah. So what do you think the coordinate for 60 would be?
1/2,
Yeah.
and then the square root of 3 over 2.
So here's your short side. That's your 1/2. And now the tall side, that's your root 3 over 2. It's the same triangle, just turned. And that's the 60. And if you forget which number goes where, think about these two numbers as decimals. Square root 3 divided by 2. Remember I said it's almost 1. It's a little smaller. It's 0.866. What's 1/2 as a decimal? 0.5. Root 3 over 2 is a bigger number than 1/2. It's 0.866. 1/2 is 0.5. Since root 3 over 2 is a bigger number, it is always the bigger side. So when you draw a 30, 60, 90, you're always going to have a bigger side and then a shorter side. The bigger side is always root 3 over 2. The short side is always 0.5 or 1/2. Okay? Because that can be tricky with the 30 and the 60. If you switch the order of the coordinate, then it's wrong. You have to have them in that order for the 30 and the 60. Okay. Any question on the coordinate? All right, so now I want you to think of that green triangle. Imagine you flipped it. Imagine that green triangle is over here. This is 180. How much would this angle be right here?
30.
That would be your 30. That would be your 60. That's 90. That's 180. Where is that dot? It's 30 degrees above 180. That would put it at 150. Looking at that triangle, that is the triangle for 150 degrees. This is the long side. What number is always the long side in a 30, 60, 90? That's always your root 3 over 2. And what number is your short side? That's always your 1/2. So you know the coordinate for 30. What do you think the coordinate would be for 150?
Negative square root 3 over 2.
Yeah. The only difference between the coordinate for a 30 and a 150 is that number is negative because you're going left. Okay? So my point is, once you know how to do the 30, the 45, and the 60, you know how to do the 30, the 45, and the 60 in any one of these quadrants. Okay. You can do all of them, because they're just mirror images of the triangle you already have. Okay, but the three numbers that you need to remember are root 3 over 2, 1/2, and then the one for the 45, which was root 2 over 2. Those are the only three fractions that ever come up when we're doing unit circle trig. That's it. Any questions on those two coordinates?
So 3 over, square root of 3 over 2 is going to be the long side.
Root 3 over 2 is always the long side. Yeah.
And then square root of 2 over 2 is...
That's a different triangle. That was the one we did earlier.
That's for the 45 one.
That's a totally different triangle. Yeah.
Yes.
That has nothing to do with this one.
Yeah, and then for 1/2 is what? It's the short side?
Short side. Yeah. Short side, long side. All right. So let's see if we can find the 6 trig functions of 60 degrees. In order to do that, what's the first thing we have to know about 60 degrees?
The coordinate.
Yeah. Okay. Let's say we forgot. We know it involves a root 3 over 2 and a 1/2, but we don't remember the order. The easiest way to figure it out is to sketch it. Okay. Here's 0. Here's 90. You got to sketch it somewhat accurate. Would 60 be right in the middle, closer to 0, or closer to 90?
Closer to 90.
It is closer to 90.
2/3 of the way.
2/3 of the way, yep. Even if you exaggerate it a little, that's fine. Okay. There's your 60. If you make your triangle, it should be pretty obvious which side is the short side and which side is the long side. Okay, it shouldn't really be much of a question. In this one, is the short side the x or is the short side the y?
X,
Yeah. And what number is the short side?
1/2.
It's a half.
And then the other one's the square root of 3 over 2.
It's root 3 over 2. So we know the coordinate for 60 is x comma y. 1/2 root 3 over 2. So the 1/2 comes first. If you just memorize it, it's a lot easier and it's a lot faster. But if you have to figure it out every time with a diagram, well, that's okay too. So 1/2 root 3 over 2. And now let's go through our 6 trig functions. All right, let's start with sine. How about Caleb? What's my formula for sine?
Sine is just the y.
It's just the y. And what's the y value in this one?
Negative 3 over 2, or square root of negative 3 over 2.
Square root of 3.
Yeah, we're.
Oh, I thought there was a negative there, sorry.
Oh, no, no
Square
negative
root
there.
of 3 over 2.
Square root 3 over 2. Okay, so we got our sine. Brett, what's my formula for cosine? Yeah.
X over y.
That's cotangent. So we'll get, that's going to be the last one we do.
You mean y over x?
That's the tangent. They're all good ones we do want to do, but just not the one I want to do right now. Yep.
X.
X. Yep. Cosine is x. And the x value in this one?
The
1/2.
Yep, 1/2. Okay, so there's my cosine. Now, tangent, we just said, is y over x. So we're going to divide them. Just imagine putting a fraction bar right there. If we divide y by x, we have the same denominator in each. What happens to the denominator?
They cancel.
Right, because you would, if you keep that the same and you change it to multiplication and flip, the 2 would go to the top and it would cancel the 2 in the
So it'd
bottom.
be the square root of 3.
So you'd have a square root of 3 in the top, and what's left in the bottom?
1.
Just a 1. So it's just square root of 3 over 1. Okay. So now we have the 3 on the left. What do we do with each one of them to get the 3 on the right?
Flip.
Yep, flip them. Okay. So let's start with the top one. Okay. Anybody think they could tell me what you get when you flip that and you fix it in case the root goes to the bottom?
2 square roots of 3 over 3.
Yep. 2 square roots of 3 over 3. So when you flip it, if you got 2 over the square root of 3, you're on the right track, but then you got to fix the square root in the bottom. How about the secant of 60 degrees? 2, because we're flipping the cosine. And how about the cotangent of 60 degrees?
Square root of 3 over 3.
Yeah, it's going to end up being the square root of 3 over 3. If you're not sure how, think of this one. When you flip it, that's your first step. But then you multiply top and bottom by the square root of 3. And that gives you your final answer. Okay. Any question on finding the 6 trig functions of 60 degrees?
Are we doing 32?
And now, yep, we're gonna do the 30. So let's try the 30. And then what I want to do is compare the difference between the answers we get for 30 and for 60. We already know the coordinate, it just switches the x and the y. So you're going to see all the same answers again, but they're all going to move around. I want to figure out kind of how they move around. So find the 6 trig functions of 30 degrees. Okay. So what is the first thing we need to know? Yeah, we've got to figure out the coordinate for 30 degrees. Does anybody remember what the coordinate is?
Square root of 3 over 2, and then a half.
Yep. So what I do, because I've done a lot of them, is I just kind of visualize it in my head. I imagine the 30 as being closer to the 0, and I say that means the long side is going to be on the bottom, and the short side is the height. So the long side, since it's on the horizontal, makes that the root 3 over 2. The short side is the vertical. That's your y. Y always comes second in the coordinate. That's your 1/2. All right, so let's start with the sine. What's the sine of 30?
1/2.
1/2.
And then the cosine is negative 3 over 2. Or square root of 3 over 2, sorry.
Cosine is root 3 over 2. And then the tangent, just imagine dividing them. The 2's are going to cancel, but you're going to be left with,
The square root on the bottom, so you have to times it by the square.
yep, and when you times it, it's exactly what Will just said, square root of 3 over 3. Now, when we do the cotangent, let's do that because we're right here. You have a choice. You could either flip what's in that box, or you could flip what's circled. They're equal to each other. Which one would be better to flip?
The 1 square root over 3.
Yeah, it would be better to flip the one that's in the box. How come?
Because then it makes it just the square root of 3.
Right. If you flip that one, the square root goes to the top and you're done. If you flip the final answer for tangent, you're going to put the square root back in the bottom again. You're going to have to fix it all over. Okay, how about my cosecant?
2.
That's going to be 2. And lastly, my secant.
2 squares of 3 over 3.
2 square root of 3 over 3. Okay, so look at the difference between the 30 and the 60. Can somebody tell me 2 functions where the answers switched? Okay, CSC and which one switched places? Looking at this page and then looking back at that page. Yeah, the cosecant and the secant, those 2 answers switched between 30 and 60. What are 2 other ones that switched?
Tangent
Yep, the tangent and cotangent,
And then the other two switched.
and then the sine and the cosine. If you read those functions, there's a pattern to which one switched. Sine, cosine. Secant, cosecant. Tangent, cotangent. The functions that switched are the ones you get when you put the word co in front of it. Okay. Sine, cosine, secant, cosecant, tangent, cotangent. Those are the ones that switched. So the functions that switched are the ones that you get when you put co in front of it. We'll talk more about that at some point. Any questions on finding the 6 trig functions of the 30 or the 60? All right. So, on the homework for tonight, there's a worksheet, has 10 questions on it. Each question has 2 parts. The first part of the question says, find the coordinate. So you're going to write down the coordinate. And then the second part is one of these 6. So you only have to do 1 trig function per problem. You're not doing all 6 in every problem. That's how the end of the homework was last night. There's 1 trig function per question. Okay. So there's 10 questions on the worksheet, and then there's these 5 from the board. Okay, so it's a total of 15 questions. All right, you got a good amount of time to work on that, so please use the time to try to get some of that done. That's a pie, yeah. And if you get the whole thing done in the next 25 minutes, you can just go ahead and show me, and then there's no other homework for tonight.
Wait, I'm confused.
Is it just
What's the worksheet?
The worksheet's on Schoology.
Okay.
That worksheet has questions 1 through 10.
Yes.
And we can just do it on Schoology, or do you want?
I would do it how you normally do your homework, yeah.
Yeah. Do you want us to show you our computer in the morning, or are you just gonna like?
You can just do it on a separate piece of paper, yeah. If you want to do it on your computer, that's fine too.
Okay.
But either way.
Is that 24 or 29?
24 pi over 8. And some of those questions are review questions definitely from yesterday. Not every one of those questions is going to be a 30 or a 45.
It's